Okay, the record is now on. So good morning, everyone, and welcome back to the semester. I think it's now open, and this is the first time for all of us. And I am your temporary instructor for this semester in your steel design class. And what you can see from the screen sharing now, I already posted this file on the Google Classroom. This is let's say it's a study plan. Okay, generally I will have 7 weeks with you. Okay, 1 2 3 4 5 6 7, as you can see, and then you're going to have the exam, your midterm exam, according to your schedule on the 8th week. Now personally, I don't really like to lecture the week prior to the exam. I don't think that's fair to students, because it's like, okay, I already told you what to do about this and then stuff. So next week I could give you the exam. I don't like that feeling at all. But according to our tight schedule, I don't know if I can make it. You know, I hope to make it. But if possible, we can try to find some time to squeeze the class, you know, here and there before your midterm exam, so that we can leave this week blank. Okay, so that becomes your reading week for me. So that's my preference. But if you guys don't mind to have a class right before the exam, well, I'll leave it up to you. We can discuss about that later. And this is the rough schedule. It's of course subject to change if we can speed things up, or if we have some hiccups, it's going to change. Okay, and I need to tell you that generally this topic, you know, the beam that is not properly laterally supported, this is the topic for the final exam. But Ajahn Sutat and I always instruct the class together. So the way we manage is that I will instruct this part, but the test itself, the exam itself, will be in the final. Okay, so if it is really necessary, we can skip this and try to find a time later on, and you can still have your reading week. Okay, that's what I prefer. So I put myself into your situation, and I tell myself, this is what I want. I don't want to have any class 1 week before the exam. So that's what I'm trying to give to you. Okay, we can talk about this later on. All right. And the next thing is that generally the first two topics, this is quite intense because it's intro, and then we start off with the tension members. So generally, even though I put it here like this, you know, it's impossible for me to finish 2 topics in 3 hours. Likely to be impossible. So let's say this is likely impossible. So we may need to try to squeeze another week during the weekends, so that you guys get everything, you know, under cover. Okay. And one more thing I like to tell you about this is that at ChemUTT we have 3 more hours for the lab, and I'm not sure about here, but what Ajahn Sutat and I have discussed is that we're gonna give you like the real problem, you know. Maybe next week I can hand you the floor plan of the real building, and your homework will be the assignment coming out of that real building, so that you can really truly design the real elements in the real building. So your homework will be taken out of the typical and practical real building. Okay, so we are pretty much trying to do the same thing as what we have done at ChemUTT, but because we have the design lab, so you can see that in this description of the class, that's why we have the design lab here, there, and everywhere. But generally, if we are going to have the class on Friday, what I can do is just the lecture on this and this and this and this and this, so and so. Okay. And one more thing is that this is not the first online class for me, so I have all the video clips available, and you guys should be aware of this because I posted some video links for you. So because we have the limited time of 3 hours, so I may not be able to show as many examples as I wish. So if that's the case, you can try to go and visit those video clips and look for more examples or look for more details in the background philosophy of the design. Okay, but in any case, please, I am more than happy to give the design lab, but you know, it's going to be sometime not on this slot. This 8:30 to 11:30 on Friday morning should be reserved for the lecture alone. And once I give you the floor plan of the building to work with, you know, if you struggle or if there are some points that you're not clear about, we can always hold a special design lab session, say on Saturday. Okay, is that crystal clear, folks? Any question?
No, it's clear.
It's clear, right? Is it crystal?
Yes.
Okay, thanks a lot. I mean, that's my signature. Okay, anyone who has come across me, they must know the word crystal clear. So now you can go and talk to anyone, and if somebody says something like crystal clear, oh, that's him, right? That's from him. Yeah, that's from me. Okay. So if it's crystal clear, we can move on from this one. And another one I would like you to see is this. Generally, we have been trying to improve the lecturing, the teaching, and the measurement of your abilities in any way we can. So this is what we have developed some time ago, and your grading will be based on this. So you can study this and see very clearly in the future how your homework and exam is going to be are going to be graded. Okay, so like this, for example, let's try to look at the first one. So let's see if we are going to measure your ability to design, analyze, and design tension members. So this is the first level. You need to be able to perform the structural analysis if you are required. For example, if you are given the truss to design, by now you should know that the truss has both tension and compression members. So you must be able to analyze the truss to, you know, obtain the force that you will design your members for. Okay, so that would be the 20% of the grade of that thing. And if you can identify the design criteria correctly, you know, use the strength of the material correctly, and because the steel design, we have two design philosophy, the ASD and LFD. If you can define that correctly, you know, you get 10%. This is easy, so then it's an extra 10%. And then if you can identify the failure more properly, because for example, you must know that when your structure is under any particular force, and in this case, we are talking about the structure under tension. So if you know how many ways tension force can fail your member, you identify them correctly, you get an extra 10%. And now in comes the main body, 50% will be based on the proper calculation. But we will not get to this point if you cannot, you know, do the first 3 levels properly. Okay, and that's 90%, but in the last 10%, you must summarize everything correctly, because from time to time, I have seen, say, students or you guys as junior engineers, you don't summarize things, just okay, After the calculation is done, and then that's it. Remember that please try to look at all your classes as the say the situation or the atmosphere that you come in and you try to obtain the knowledge that you can use in your professional career. Don't think of any class as a pass or fail or the exam anymore. So when you go out and work in the real world, you know the situation, you can find a solution to your situation, and then in the end, you must be able to summarize what are you going to do in the end. Okay, and from time to time, if the problem requires something extra, you may get the extra 10% if you show the good engineering judgment. Okay, so yes, we can go beyond 100%. So that's how your work is going to be graded. So is there any question on this one? And generally it's pretty much the same, but we change from tension to compression to flexural members and so on and so forth. Okay. According to my experience, not many of you will pay attention to this, until you have to. So, but I want to let you know first, okay, just to be fair, that if you really want to know how your work is going to be graded, this is it. This is how. I think it's very fair to students for them to know what is expected of them. So when you come in to the class and you complain that, hey, I don't get any points. Why? See, I can design it, but you fail at the structural analysis. So I would say, okay, it's shown here that when you want to design something, you must be able to calculate or analyze the force of the system, right? Otherwise, it's useless, and it's pretty clearly stated here. So you should not have any doubts about your grading and so on and so forth. And now you should know that if you have any lingering problem from the structural analysis class, you should try to make things clear from now, because it's pretty obvious that if you cannot analyze the structure, you cannot design it. Okay, so this is what is expected of you. But again, yes, you need to perform the structural analysis from time to time, but it's not going to be something like, oh, side sway moment distribution, that kind of stuff. It's just going to be some proper analysis. And because I say this is the purpose of this class, just to try to give you the ability to design simple structure. Okay, so the analysis here should not be more than, say, typical determinate structure and stuff like that. Okay, so is there any question on this one?
No.
Not at all? Come on. Anybody done? Any question at all? Maybe we can talk about rock and roll later, but not now, football. Yeah, let's keep to engineering for now. Okay. Maybe I should give you the course portfolio as well, but I think I just, maybe I overlooked that detail a little bit. I didn't forget about it, but I need to discuss about some percentage of the class with Ajahn Sutat, and maybe I need to ask SIIT, because I don't know if they're going to give Ajahn Sutat and I the complete freedom on this. I'm saying this because we changed the percentage in the past 2 years because of the COVID situation. So we based more percentage on the homework, which is the design project by itself, because your homework is going to be the design of the building. So we give more percentage on that, hoping to help students coping with the situation better. I don't know if we are allowed to do that, because we are, we're not a permanent staff at SIIT. So let me check on that, and I'll confirm this with you guys the the next class. So far we are good. Are we good? Hello, talk to me, please.
Yeah.
Are we? Am I talking too fast?
No.
No? Am I talking too slowly?
No.
Not no either. Okay. All right. Ooh, one second. One second. Terribly sorry about that. Ooh, he's like 9 years old and always has problems. Anyway, if you don't have any problem with that, and I'm not talking too fast, I'm not talking too slowly, so let us try to get a head start on the subject, okay? And before anything, before I start on the chapter 1 of the lecture, let me try to, you know, get you guys into the system of thinking about design. Let me ask you one thing. Have you taken the RC design class before this semester, or are you taking it this semester?
Taking this semester.
Okay,
Yes.
great, cool. Thanks a lot for participating, okay? So I feel I'm a part of you now, okay? So, you know, what is design? Let me ask you this. When you want to design something, it means that nothing ever existed before that, okay? I think this is the beauty of engineering, because we create something out of nothing. And when I say something like this, I tend to go towards the structure, because I'm a structural engineer. So please forgive me for those of you who aspire to become, say, water resources engineer or transportation engineers. You know, it's your freedom. But anyway, let's say we are talking on the same wavelength about about design. When you want to design something, that means that thing never existed before. So it's the engineer's job to gauge the situation properly. And when we talk about the design, we are talking about two things. Okay, we are talking about the load. Okay, your job as an engineer is to create the structure that has the strength to withstand the load. So this is the basic equation of your work, that the strength of your structure must always be greater than the requirement posted by the load. You guys with me?
Yeah.
Okay, so the load that we are talking about here, let's hope that you understand that we are talking about the forces, you know, induced by the load, perhaps, because let's say when we look at one building, the architects will have the job to come up with proper function of the particular building, right? Let's say if it's a hospital, they need to make sure that they have all kinds of ward rooms, operating rooms, and so on and so. And we need to make sure that we will provide proper structure so that those rooms, those functions will not collapse. So we as engineers will perform structural analysis to get the forces acting on all the members. But that also after we as engineers give this, the building a proper structural system as well. Now when we have the forces, we need to select or design, the member so that all the members that we design have the strength at least equal to or more than the forces that the structure have to carry. All right, so when we talk about the load, generally you should know that this part, do you know that this involves law? When you are going to design one building, you must know what laws pertaining to the design of such building. For example, to put this into a better perspective, I should say that the law will say that, for example, we talk about the hospital, right? So the law would say that the hospital must be able to carry the loads this much and that much. We call that life load. You guys know what life load is, right?
Yes.
Yes, okay. So life load generally is the load that directly involves with how the building is used. So in the US, they call that the occupancy. For example, the hospital usage will be different from the school usage or the university or public place or the concert hall. That is what we call occupancy, how you're going to use the building. And the law will state that, such particular building must be able to withstand the life load equal to this, and that. Date load, the law will state that, okay, you need to calculate the date load to account for blah, 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 but the date load is pretty straightforward. And the law will also state that you must account for the wind load and earthquake and stuff like that if you are in particular region of particular country, so and so. So it is absolutely important that you know the laws that involve with your work. For example, if you're going to design the building in Thailand, you must know the Building Act or กฎกระทรวง นะครับ. If in the future you work and you are involved with the design of the building in Cambodia, for example, so you must know their law about the building. So this is the load side. This is the what you need to know about the load side or the demand. We can say it's a demand. Now, our job as an engineer, we must provide the structure that is strong enough to withstand the required load. Right? So we need to be able to predict the strength of the structure or member, I should say member, or pretty much the same thing. And you must have noticed that you have had the class like mechanics of materials that will give you the basis on how the load affects the materials, right? And now that class should give you the general idea how the load can cause the stress and strain in the members and so on. And some basic load will cause the axial stress, like compression, tension, and so on. And some load, when it becomes perpendicular to your member, that will cause flexural stress or shear stress, or whatever. Now, when we come into the particular class like this one, you will learn the particular characteristics of the material that you use, and in this case, steel. And so you will be able to predict how steel can handle each kind of load based on different stress that occurs. All right. So generally, this will involve, say, because we Thai people, or at least we are having a class in Thailand, so we use the predicted the prediction based on AISC, or the American Institute of Steel Construction. So that is not the standard. It is called specification. But due to some silly complication in this country, they say you cannot call that specification. So when they, try to relate AISC into what we have as EIT, they call that standard. But you guys should know that when you talk about the AISC, the American Institute of Steel Construction, they call that part specification. But for EIT, they call it standard. So please call it correctly. If you call AISC standard, if you talk to American engineers, you're going to be embarrassed. Okay, so call it by correct name. So this involves this, and the bottom line about this is that you should know that these two are not law. Okay, they are, I should say, guidelines that help you predict the strength of your structure. So maybe I should change the color to differentiate this a little bit. Okay. So they are guidelines. They are not law, meaning you don't have to follow them, right? If you don't like them. But whatever you do, you need to abide by the law. So whatever you do, you need to make sure that the structure that you are going to design, that you are going to build, must be able to handle the load and the forces that the law says. How are you going to predict the strength of your structure is actually entirely up to you. If you don't like AIC, if you don't like EIT, can I not use them? Of course, absolutely. Do whatever you want. But if whatever you do doesn't have any, proper background research or test or, something to back them up, and something failed, it's like you're on your own because you don't follow the proper guidelines given to you by, say, very, very professional engineers and instructors in the field. These AISC and EIT stuff, they say, let's say they're not Bible, you don't have to worship them. You don't have to completely, under the influence of them. Engineers who always talk about this without knowing what they are for, perhaps they don't really know what they're doing, and they are hiding behind the spec. Now, these two are very good, I have to say. That's why we can use them as guideline very effectively and very efficiently as well. So generally, when you follow these guidelines, you are quite safe. Okay, but let's say they're not completely sacred either. The changes always occur. So they want to streamline, make things better. So that means they're not absolutely complete or correct all the time. But whether or not the law is correct, you have to abide by them. Okay? And when we are going to design something, what we will do is that we have to know the load as suggested by the law, not suggested, as enforced by the law. And then you will make sure that you can use the load bigger than the law says. If your engineering judgment say that, okay, I think this building is going to be pretty special, and after talking to the owner, the proper force that I should use should be this and that. They can be greater than what the numbers the law suggests. It's up to you, but it cannot be lower. Okay, so once you make sure that you know the load that you have to deal with, now you perform your structural analysis and you design your members or your system so that they are strong enough to take care of the demand. Okay, so this is basically the concept of the design. It doesn't matter what you design for. If you design a concrete structure, it's the same concept. If you design the foundation, if you design the piles, the retaining wall, the dam, the road, same thing. So is there any question on this? Hello? Hello, are you asleep? Hello?
No question.
No question, really, ma'am? Don't you want to, you can ask anything, even if this is okay with you, maybe you have some doubt in your mind, really? And what if I don't use this specification? Am I going to be okay or stuff like that? You can ask me anything.
I think we don't have now.
Okay, right. You say you don't have it, and it's like I keep on insisting that you ask me something, right? So that's my bad.
Maybe later.
Maybe later. Okay, thank you. So let's move on more specifically into the steel structure, but the concept is going to be the same as this one. So let's say if it's a steel structure, it's the same, except that now we have two design philosophy. You may have heard of them already, but you try to do it this way. Okay, let's say this is a load. Okay, and this is the resistance. We always use that word, right? In steel structure, there are two design approaches or two design philosophy that you may have heard of. The first one is called ASD. This stands for, I don't know if I'm going to be able to squeeze this in. Let's try. This stands for allowable strength. In the old days, it used to be the word stress, but they changed it to strength, and D is for design. Okay. In the load here, we will use the load that is called service load. Okay. And then there is this method called LRFD. This name is pretty long. So this stands for load and resistance. Factor, design. Okay, the load that we are going to use here is the ultimate load or factored load. This is service level. Okay. So before I get into more details, I think I should explain something to you. Have you heard of the word nominal? Have you heard of the word nominal before?
No.
No? Excuse me. Bad pronunciation by me. Nominal. Now, you know, I have to say that when I was your age, when I was in the university, I never understood this word. And my life was a living hell because I could not understand what the meaning of the nominal is. Now, when we talk about, you know, the nominal strength of the structure, generally it means the calculated strength. So nominal is the calculated strength. It's something like maybe, for example, from your idea of mechanics of materials class, you know that if you know the strength of your material and you know the area, say if you know the strength, the force that this say member can carry, the tensile force that this member can carry will become the strength multiplied by the area. Am I correct? Based on mechanics of materials. Yeah, right. So it's a simple idea. So let's say the force here R will be equal to the strength multiplied by the area. Now, the number you get from this calculation is called nominal strength. The strength that you can obtain from calculation or from test. If you know, if the strength that you have here is not the number that you take it from someone, it's from the lab. You go ahead and calculate this, you're gonna get what we call the nominal strength, denoted by Rn. Okay, so are you still with me so far? So the nominal strength is the strength that we should be able to calculate, you know. But in engineering, let's say, okay, now I know the strength of this material. Should I use all of them in the design? Would it be safe, you ask?
No.
No, right, great. It would not be safe. No. For example, if this is a nail and you know the strength of the nail, you know the area, then you calculate, you know that this nail can perhaps carry the load equal to 500 kilonewton. So you're gonna hang something equal to 500 kilonewton with this nail. Let's say if I make it more practical, you know, a typical car weighs about 1.5 tons, so to speak. Okay, so technically, if you have a nail that can carry tensile force up to 1.5 tons, you can hang the car with that nail, right? Figuratively speaking, just the numbers, right? You can say, hey, actually I can hang the car on that nail because the nail can carry tensile force up to 1.5 tons and my car weighs 1.5 tons. So my car should be safe. Would you do that? You wouldn't. So we engineers cannot use the nominal strength to design something because we need to make sure that everything is safe. So in the engineering world, nobody uses the nominal strength to design something. We use design strength. I should try to write more. Is not used. Design strength.
It mean it's work in calculation, but not work in practical work.
You can say that it's close enough. Yes, you can say this is what I can calculate, but I will not use that number from the calculation in the real world because it's not safe. I need to have some kind of safety within me, right? So I need to make sure that my final strength is safe. So I will not use the nominal strength. That means a complete total strength of my structure. Because for example, let's say, what if I measure the area wrong? What if the area that somebody tells me, okay, your nail has the cross-sectional area equal to this? What if it's wrong? Or what if the strength that you use is not what it is? Because when let's say when you want to know the strength of your material, right? You test one nail and you can measure the strength from the test. But the nail you use is not the one that you test, right? Because the one that you test has already been destroyed. So you cannot use that. So in fact, you would never know the strength of the nail that you have for you to use. Am I correct?
All right. Yes.
Yeah. So this is the philosophy that you must feel first before you design something. So right, we cannot use the nominal strength to design the actual structure. We must use the design strength. Is used. And the design strength is something that has been reduced from the nominal strength. Okay, so now we know the word. When we talk about the strength, we should talk about the design strength, not the nominal strength. Okay, for example, you guys must have known the factor of safety, right?
Yes.
Yeah, so this is where the factor of safety comes in. We will reduce the nominal strength into the design strength either by using the factor of safety or reduction factor. In ASD, we will reduce our nominal strength by dividing it with the factor of safety. Okay, so now let's say if instead of saying, okay, I know that the nominal strength of the nail is 1.5 tons. So I'm going to hang my car on it. Now, instead of that, when somebody say the design strength of this nail is 1.5 tons. So now you know you can hang your car with factor of safety. That means generally that nail is stronger and it can actually take care of the tensile force more than 1.5 tons. If we say it's the design strength, now you can hang your car with the much better feeling because you have factor of safety. So we can always calculate the nominal strength of the structure, and then before we are going into the real design process, we must make sure that we reduce it into the design strength, and then we will make a comparison with the service load. Okay. And for the LIFD, we don't use the factor of safety. We use what we call the reduction factor to multiply this. Okay, so that's the general concept. And you know, I have to tell you this. I don't lecture 3 hours straight. I don't think anyone can handle that. So we have 3 hours together. After 50 minutes, I'm gonna give you a 10-minute break. That good to you? Or you guys, we want all 3 hours. Hello?
Just give us a break.
Okay, so that's what I always do, because you know, for me to talk 3 hours straight, that's very, very horrible as well. So let's say